Enabling virtual product validation. Actually, today I'm celebrating my 7-year anniversary on that topic. And you asked the question, how safe is safe enough? There's no easy answer to that. It's a very layered problem. And I think what I want to give to you today is a little bit of an overview on the different pillars that I think are important and you should have a look at, or at least I think you should have a look at. And then I will also give a little deep dive in a specific topic. I structured it in a way that in the top right, so you can take out your mobile phones, I have QR codes to lead to the specific deep dives on the topics that I will talk about. And today, the deep dive will be about model quality. And I will also hit the topic of digital identities and all of that with the goal of enabling decentralized data markets, because data is a very important thing to have validated in order to give a proof of validation. So can I say with certain certainty that a function is good? What is the first pillar, in my opinion? It's open source. And my journey in 2017 started with just one commit, and it was the commit of the Open Simulation Interface. And the Open Simulation Interface, and I introduced that in 2019 here at the OSS.5 as ASAM OSI, it's an interface to integrate sensor models. And the base idea of bringing it open source was that an aspect of safety is that as many people as possible should be able to have a look at it. So I want to put it in the open so that you can evaluate it. And also it was important to get transparency regarding architecture and interfaces in order to build up a modular development framework, to be able to integrate models and tools from experts that are here on the conference, to not only exchange sensor models, but to have the vision of exchanging maps and scenarios and 3D environments, and taking the pieces from those specific experts that I need to have them from. And all of that to reduce cost and time. And this pillar of open source led to the next one. And the next one is actually standardization. So with OSI, we kicked off the ASAM OpenX simulation standards in 2018. That's where we laid the groundwork. And it was a new business model. We transformed it into free and open standards that everybody could have a look at. And in order to participate, you needed this framework to be compliant with law and to be guided through the process. And that's why, with the wish to participate, over 200 new members joined there. And we have ASAM now, we have it in Japan, we have it in China, and it's built up in Korea. So it is a great success story. And the OpenX are now a topic of every major tool supplier. And I think last year, ASAM was celebrating 25 years of existence. So even after 20 years, we could make a change in that organization that led to the biggest growth. So you should never be afraid of making radical changes to existing structures in order to accelerate. Standardization, the second pillar. The third, I would call it co-opetition. It's a mix between cooperation and competition, because we are all competing with each other somehow. But as I said, in this modular framework where we exchange data, we all need to somehow cooperate. in order to have an understanding of the things that we are exchanging. So we are part of this network where all of the data flows into a simulation tool. The tool is used to build models. The models are given to OEMs, and the OEMs are trying to prove something to an authority. And this is all kind of a network in which we need to answer different questions that we have, like how can we enable this flow of data? How can we establish quality? And for the competition aspect, you also need to establish networks. So we established the ENVITED research cluster, which is standing for Environment for Virtual Test Drive, at the Automotive Solution Center for Simulation. It's a similar club like ASAM, but not with a focus on standardization, but the focus on bringing research close to serious development. And last year, I talked about one of these challenges, and I think it's the next pillar that we have to remember. It's that we should always try to integrate new innovation ideas, and in this case, I'm talking about the digital twin. So I will go over this briefly, but the important thing is that if we talk about standards, you always have to keep in mind that you're not building one monolithic giant standard that covers everything, but you have to be able to put them together and layer them above each other. And I will give the example on a sensor model. So if we think like this, this represents a sensor model, then you could say, right, I know how to do that. I take ASAM OC and I package it as an FMU, but if I take this and I give it to you, you will not know what it is, because the meta information is missing. So in order to create a representation for it, you have to give it meta information, for example, with simulation resource metadata that comes from system structure and parameterization, or you can go into another layer of a new technology, for example. In this case, we made a case study with a blockchain technology to tokenize that specific piece of data. And tokenization and digital twin stands here for the same thing. So you build a representation of a piece of data, and you add meta information in order to understand it, and then you create an instance of this data, for example, on some kind of storage like IPFS, randomly chosen here, and then you create a digital twin. And the digital twin can be brought on another system, for example, a distributed technology. And in this case, all of that, and you can see it in the GitHub in the top right, has been built with public infrastructure, open APIs, and open source tools, and open source libraries, specification, and standards. So you can see that the things that I said before, standardization and open source, and something new, like an innovation, can be brought together to build easy examples to understand something like a digital twin. So the next thing, if you create a digital twin, you can ask who is creating a digital twin. Because we are all here in this physical world together, but in the digital world, we also need a representation of ourselves. So we need a digital identity. And we need to create this digital identity in order to interact with each other in a secure way. So what we are also doing in the ENVITED research cluster is that we're building a decentralized identity management system for the members. And what is that? A digital identity, you could say the traditional way of having an identity is to use your email and password to create an account in every application that you use in every service. You always use the same email, you always use the same password. One of those gets hacked, and you lose everything. Now, what was the solution to that? It was federated identities. You sign in with Google, you sign in with Facebook. Now you trust a big company who knows about security to handle this well, and you provide an API. But you centralize this identity to a specific company. And now the next step is to be the owner yourself of that identity. And to use a decentralized technology in order to provide the security and to have the ownership of this identity yourself. So what does this mean? It means that your identity that is consisting of certain attributes, like my name, I'm Carlo, I'm 35 years old, and there's now the question of who can attest for those attributes. So I'm claiming that by myself, but somebody needs to attest it. My age, I don't know, you could ask my mother maybe. And for something else, like where's my bank account, you can ask my bank. So there are certain entities that could attest for certain attributes that in its whole make up my identity. So this is the base idea of a digital identity. You create certificates that are attested by somebody. And we are using a structure like an automotive club, which is a representation of the companies that are part of it, to give attestations for attributes. So it's called the trust anchor system. The trust anchor, in this case, is the automotive club that we're trusting to attest certain attributes. And then there's BMW who says, I am BMW. And the trust anchor attests it. And now there's me as an employee, and I'm an employee of BMW. And BMW is now attesting that. So you see there's a chain of trust and the attestations of the certificates. And this is the whole baseline of it. What you use for it, you use decentralized identifiers to attach those attributes to. You have a public registry to claim the validity of those attributes. You have verification libraries to accept and verify these credentials. And this will, as a certificate, replace your login. And from an architectural point of view, so as a user, you have a wallet application on your phone, and it carries your verification, and you can hand out verified claims to others. And with those identities, you interact with each other in that network that I've shown before. The architecture of such an application is quite simple. You have a trust anchor that runs a web application. It's, in this case, called DEMIM. It has a credentials API and a database. And an administrator says, I'm the trust anchor. Now we have to sit together and just acknowledge that. And then companies register their identity there, and it's attested by the trust anchor. The same thing is happening with an employee. And eventually, any verifier can just verify this claim. And the credentials itself are just temporarily stored because of GDPR, and then just placed into the personal vault, for example, on your mobile phone. And this is a key enabler for the exchange of data in a decentralized ecosystem. So a very interesting topic, and if you like to hear more about it, contact me and or the industry club for it. It's a key enabler, it's one of the pillars, digital identities. What kind of other ecosystem challenges do we have? So let's go back a little bit more to our daily problems of data. So I always like to ask what makes a map HD or a scenario relevant. Do we have the same understanding of the underlying standards, like Open Scenario, OpenDRIVE? Do we use the same feature sets of the standards? Or did we leave something out? And what kind of quality measures have we taken? And is that actually tied to a specific use case? I have demonstrated before that you can tackle this problem top-down. You can go into the regulation document, UN R157 for ALKS. You can analyze it. You can go into the annex and see, okay, what scenarios do I have to test? And you can write down those scenarios. You find them under the link, implemented in Open Scenario. But I also want to show you that there is a bottom-up approach on quality. And it's more on the second point from the bottom, what general quality measures have been taken. And I want to demonstrate that at the example of a sensor model. But it's kind of generic. You can apply that to every type of model, if it's steering a motor or something else. And I think it's one of the most important pillars for us. It's having best practice examples that we are building together. It doesn't help if you understand how it's working. We need to understand it. And if people talk about open data or open source, they're always afraid that you take away their business model. But it's not the point. The point is about teaching. I'm doing that because I want to teach and I want to learn. And at the ASCS, we created something very simple. It's a GitHub organization. It's called the Open Source Model and Simulation Library. And it's explicitly there in order to provide best practice examples for the ASAM OpenX universe. I'm calling it universe because everybody who does something with it will realize you can do it for 5 years and still have questions about it. So it's open source, it has a very lightweight governance for compliance, and it is a community where people teach each other. And what we did is we brought in examples from research projects, something that, I wouldn't call it a pillar here, it's too much, but research projects enable us to collaborate somehow, and you create examples. We created examples for reflection, LiDAR models, and radar models, also part of the library. We put them open source, and we put them under governance. So if you put something open source, you still have to care about the community who's further fostering that. So in this case, we created a community of people who care about perception sensor models. And we derived templates from it. So it doesn't help if I just have a radar model. It's maybe useful to understand certain methods or something, or how it's applied. But it's very unlikely that you use that in production. It's not the point. But if I have a second person that is interested in implementing a model, they want to have a template to understand how all the things work in between, the standards with each other. So we created a template, and we put something important on top of that. And that's another pillar. It's a process for quality. And it's the credible simulation process. It's coming from, well, was also mainly developed in a set-level project, research project. And if you say a name of such a process, some may heard of it. A few have read the documents, and even fewer have an idea of what it means. I always need practical examples. So what I did is I'm implementing it in an example. So, okay, this is my idea and vision of a credible modeling process, and I think this is how you can do it. And this is what you will find if you go on GitHub, go into the workflow, and look at the CI, and you will see the different executions of the steps of the credibility assessment level. First one, a very simple one, 0, it's the license check. Am I allowed to use it? A few people know that you need SPDX license identifiers to be able to say if you can use code or not. Maybe a very simple thing, but you have to be aware of it, and it's astonishing how many people forget that. You can automate it. Second level is code verification, credibility level 1. You apply linters for C++, Markdown, XML schemas, files. You you CMake and build the FMU, you check for FMU compliance, you do unit tests, and you have to make people aware that those things are necessary to hit a certain level of credibility. Credibility level 2, and I'm saying that because it's a proclamation, okay? So I'm hitting on that wall, credibility level 2, this is what I think. And you as a community, you have to decide if you think the same way and engage with me. I'm saying this is smoke tests, it's interface tests. So if I have a model that has an input and an output, I want to check if in and output matches my requirements. I want to know if I put in a coordinate and I get out a coordinate, and I check the fields. Simple as that. And if you check it according to requirements, this is for me credibility level 2. And I want to have automation for it. And I want to have a proof of that. How does that work? If you go in the pipeline, and I think this is very cool, you see a complete co-simulation of models. We're using OpenMCX from AVL. It's a co-simulation platform. We use only standards in the whole architecture. We use system structure and parameterization to define the architecture. The architecture is loaded by OpenMCX. It's executing using specific FMUs that are part of the library for playing a trace file, like an OC trace file, evaluating trace file, or even playing scenarios. We're integrating ES-Mini from Emil Knabe, from Volvo, wrapping it as an FMU, putting it in the architecture, executing it. So if you ever had the question on how does it work together with all of the standards, just go in the pipeline. Clone the repository, and you will see how it works. Credibility level 3. It's quantitative verification, and this is something I think it's kind of difficult. We started that beginning of the year, so this is the next step where I want to head. It's, in my opinion, the comparison between expectation data and data that's produced by the model. For example, you're making you collect data in the car from the sensors, and you compare it maybe to a simulation, or you analyze the data, whatever. So it's more, it's a little bit more than the step before, okay? And what I have in mind is that you compare, you make analysis on those trace files. So maybe you have in the requirements something like you expect something to be Gaussian distributed, right? You can analyze it and check it. If it's not happening, then you know there's a problem. It's very much depending on the requirements. And what do I think is interesting? We now have a group at ASAM, which is called Open Test Specification. And this is more like the idea of this top-down. How do I have to specify tests? How do I have to roll it out to different instances, Hill, SIL, or whatever? And what you've seen here is more the bottom-up, and those have to meet each other somehow. And I want to implement those things open source in order to demonstrate how you can derive from requirements the different steps to go into the code and the model and compare it. And to make people aware on how to use the different specifications. If you're interested in that, approach me, become part of the community, get engaged, learn and teach others, and implement it in your products. Because if you want your product to be acknowledged somewhere at the company, this is a great way of demonstrating that you have understood the complexity of a network and how things work together. It is universal, it can be used for different kind of models, it's accessible, it's adaptable, it's easy to use, and it's all integrated in continuous integration. So thank you very much for your attention.
Thank you, Carlo. Do we have any questions from the audience? Okay, I see one question.
Thank you, Carlo, for a nice talk. Martin Thorgren from KTH. I was wondering, maybe I missed it in the beginning, but you did not refer to tool qualification, which would somehow be related, and also the experiences from model-based systems engineering, where validation would be extremely important. I'm not sure to what extent you included that in your verification.
Tool qualification. I start with the things that I find a little bit more easy. So if I have to evaluate the tool itself, it's like a very big thing. So I start with the small elements. I want to evaluate the certain pieces of data that go into the tool first. I want to evaluate the different models that a tool is loading maybe first and have some kind of, I would say it's kind of, you have a tree where you have a dependency of trust between the different elements. And the tool is, for me, very much above. And I think part of the tool qualification is that it works together in such a system. So I think a lot of people would agree that ASMini, even if it's an open source tool, is a very great way of using OpenScenario. I hear from a lot of companies that they say, how do you know that your OpenScenario file is fine? Yeah, I did run it with ASMini. It's kind of, I don't know, it's like a knighting, right? So because it runs and it works in a lot of contexts, it gives people the idea that it's good. So it's part of the tool qualification that you can use it and you entangle it with each other. So, and I want to entangle the different tools and elements with each other in order to get an idea of quality. It's kind of implicit, but I think it's a good way of approaching the problem.
Do we have any other questions from the audience? Yes.
Marek Musea from Carriot. Thank you for your talk. You mentioned the word proof in the different steps of verification. I was wondering a bit, like especially in the TBD column on the right side, we were going more towards plausibilization. Maybe could you maybe repeat a bit or explain a bit? If this proof is meant, if you meant it literally or not so much?
No, it's a good question. So, what is considered a proof, right? In certain departments, you take a software component as granted if a department lead has signed a document, right? So that's a proof, right? So it's more like, I'm mocking it a bit, but there's obviously a process behind it. I think the idea is that you establish a process, you make it transparent, and people can own the process, can change it, and understand it. And if you apply the process and you can prove that you have applied it, then it's an overarching proof that you can give trust. So that's what I would call proof. So, but yeah, it's a good question.
Yeah. All right, thanks.
Do we have any other questions? No? Carlo, then thank you so much.
Thanks.
For your presentation.